Now next in the integration is here product rule, or it is in general called integration by parts. Integration by parts. This is not exactly product rule, but one type of product rule. More or less it's look like a product rule. Okay, so we start with two functions of x. Let u and v be two differentiable functions, in fact functions of variable x. Okay, and then we consider integral of this type u v dx. So these are the two functions, product of two functions. Now with the help of differentiation this can be derived. I'm not getting into the proof, I'll write directly. This is the first function u, this is the other function v. So this integration by parts rule says that you take u outside, just do integral of v, minus inside the integral differentiation of the first function, that is du by dx, into integral of v, and then whole integral. I repeat what I did: u outside, integral of v, minus this is outer integral, this integral symbol and dx. What you will do inside this here, differentiation of the first function du by dx into integral of v. This is same, you see, same thing here. Integrate v du by dx and simplify, and then you integrate it. So you are not integrating this directly, you are doing in different parts. So a single integral is reduced into how many integral? 1, 2 and 3. So one integral is converted into 3 integrals. That's why it is called in parts, by parts. This is called integration by parts rule, remember. I repeat what it says. It says that you take u outside, integral of v, minus inside the integral du by dx into integral of v. This one and this one will be same, remember. So this is a type of product rule, or you can call the integration by parts here, remember. I repeat one more time: integral of u into v, this is a product of two functions, u outside, integral of v, minus inside the integral du by dx into integral of v, then whole dx, remember. This is called parts rule, integration by parts. Integration by parts rule, remember. For example, let's start with x into e raised to x, product of two functions. Now you recall all earlier techniques. We did linear upon quadratic, we did partial fraction method, we did substitution. Using previous techniques you cannot solve this. The only way to do this one is integration by parts, remember. So here I'll consider, for example, this as u and this as v. Just we'll keep this one in our mind. The first one is u and the second one is v. Okay, and then I'll use above integration by parts technique. So I'll write here integrating by parts. Now what is integration by parts technique? U outside, x will come outside, integral of e raised to x, minus differentiation of u, that's the derivative of u with respect to x, which is 1, into integral of e raised to x, and then whole integral here. So this is equals to x into, what's integral of e raised to x? E raised to x. This right now as it is. What is this inside this? That is e raised to x, the whole dx. And now finally this is as it is right now. What's the integral of e raised to x? E raised to x. Plus at the end we put the constant of indefinite integration. If you want, you can take e raised to x common, so we'll get the x minus 1 plus c. You can write like this. You can verify if I differentiate this or this, I must get this, remember. This is what integration by parts rule. Now if you just recall here, I told you in the beginning that you take this as u and this as v. I told you take this as u and this as v. Now the question in our mind is, suppose you are given like this, for example. You are given like this in the question itself, e raised to x first and then x. Now can we take this as u and this as v? What I did, you know that this is same as this. What I did, just in the product I have interchanged these two. Can we take this as u and this as v? You can verify, your sum becomes more complicated. See, if I take this as u and this as v, if I use integration by parts, e raised to x outside. So I'll write e raised to x here outside. Into integral of x, which is x square by 2, minus inside the integral here, derivative of e raised to x, which is e raised to x, into integral of x, same x square by 2 and then whole dx. You see, this expression is more complicated than this. So this is not the correct choice of u and v, remember. U has to be this and v has to be this. That's what I've explained. So now question is, how do we select u and v? So there is a standard technique to select u and v for the product of two functions in integration by parts. So I'll write here the selection of u and v, selection of u and v should be done in this order, should be done in the following order, That means in this order, whichever comes first should be taken as u and the other one should be taken as v. Now the order is this here, Liet rule, L-I-A-T-E, Liet rule. Which rule? Liet rule. What is L? L is log function. What is I? That is inverse trigo function. Inverse trigo, you know. Inverse trigo means sine inverse, cos inverse and so on. Okay. What is A? That is algebraic. What do you mean by algebraic? That is constant, like 2, 3, then x squared, then 2x plus 1. These are called algebraic functions. T, you know, trigo. E, log, and now one more standard function left out. It is which one? Exponential. That is 2 raised to x, 3 raised to x, e raised to x, 10 raised to x. These are all exponential functions. So in this order, the selection of u and v should be done. Whichever function comes first, taken as u, and the other one should be taken as v, remember. In this order, the function that comes first should be taken as u and the second one should be taken as v. The selection of u and v should be done in this order, Liet order, remember. I repeat, L stands for log function, I stands for inverse trigo functions, A stands for algebraic, x squared and so on, T stands for trigo functions, E stands for exponential function. Now you recall that example, x into e raised to x. It is a combination of which two functions? You know, algebraic and exponential. This is algebraic, this is exponential. So in this sequence, which comes first? Algebraic. A comes first, so that should be taken as u. Which comes next? That is exponential, so this should be taken as v. Suppose I have this, for example, log x into, let me write x, product of two functions. You can do it by parts. How do we select u and v? Look at it, Liet rule. In this order, which one comes first? Log comes first. So this has to be u and this has to be v, remember. If you do other way around, sometimes it cannot be integrated. In some of the question it may be, but this is very standard common technique, remember. Suppose I have this one, x squared into sine inverse x. This is a combination of which two functions? Algebraic and inverse. Now in this order, which occurs first? Inverse occurs first. So this should be your u and this should be your v, remember. Inverse occurs first. So sine inverse should be taken as u and this should be taken as v. Okay, suppose I have this one more. If I write one more functions. For example, I have, let me write here, 2 raised to x into sine x. Combination of which two functions? Combination of exponential and trigo. In this sequence, which occurs first? Trigo. So this should be taken as u and this should be taken as v, remember, and then do by parts. Suppose I next have 2x plus 1 into 10x. Combination of which two functions? Algebraic and trigo. In this sequence, which occurs first? Algebraic. So this should be taken as u, this should be taken as v. I hope now this is clear to you. Sometimes if you have single function, if you recall, so far we have not done integral of log x. You recall all standard functions you did. We have not done integral of log x. Do you know any function whose derivative of log x so far? No. Now you can answer this. Now this is a single function. So what we do in such questions? I'll write log x into 1. If you have single function and if you want to integrate, you can write into 1 and you can do by parts. Now tell me, this is a combination of which two functions? Log function and constant means algebraic. So which occurs first? Log function. So this should be your u and this should be your v. So this way you can use integration by parts. I hope this is clear to you. So let me do now integration of log x here. I'll do integration of log x as I explained. So how do I do? I'll write log x into 1 and then we use uv rule here. So we call this as u here and we'll call this as v. You know, according to which rule? Liet rule. As per Liet rule, log occurs first, that is u, and constant algebraic occurs later. So this should be your v and this should be your u, remember. Now we do by parts, integration by parts here. So according to integration by parts, log should come out, log x outside, integral of 1 minus inside the integral derivative of log x, which is 1 upon x, into integral of 1 and then whole dx. What I did? Integration by parts. U will come out, integral of v minus inside the integral differentiation of log x, which is 1 upon x. यहाँ पे आपने जो लिखा वही यहाँ पे कॉपी करना है, into integral of 1 and then whole dx. Now we just simplify. Log x into, what's the integral of 1? X minus 1 by x as it is right now. What is the integral of 1? Which is x. Same answer, these and this. And then whole dx. So this is log x into x minus, what is this? This is just 1 and now we integrate it. So log x into x minus x integral of 1 plus c. Integral of log x. What's the integral of log x now? Log x into x minus x plus c. If you want, you can take x common. So you will get the log x minus 1 plus c. This is your answer. You just verify if you differentiate this or this by chain rule, you will get exactly this. Now here, based on this, we have one result. Let me write. So that says that integral of e raised to x, this is fixed, exponential function, remember. And inside the bracket, if you have function plus its derivative. I repeat, e raised to x into, inside the bracket you must have function plus its derivative. Then the integral of this expression is e raised to x into fx plus c. Right? It can be proved by parts. We are not getting into it. But if you differentiate this, you will get exactly this. You can verify. What I am saying, I repeat the result. Integral of e raised to x into, inside the bracket, fx plus f dash x. Then this integral is given by only e raised to x into the function fx. This is the answer, like this. Let me write here as an example. E raised to x, suppose I have 10x plus let me write 6 squared What is the answer to this? According to that result, this is f, this is f dash. So answer will be e raised to x into 10x plus c. This is the required integral. You just differentiate this, you will get this entire function. So if you have such things, e raised to x, inside the bracket if you have function plus its derivative, you can use this result. One more, suppose I have here e raised to x ही होना चाहिए. Remember, I have 1 minus x upon x square, for example. Now what I'll do individual division inside the bracket. So I have e raised to x as it is, this upon this, that is 1 by x square, minus this upon this, that is 1 by x. Now you can see that if you notice it carefully, inside the bracket you have function plus its derivative. Which one is the function? This is your f, remember. What is derivative of 1 by x? Minus 1 by x squared, if you recall. What's the derivative of 1 by x? Minus 1 by x squared. So this is f and derivative is this. So what is your answer? E raised to x into f. What is f? Minus 1 upon x plus c. This is the required integral in this case. Okay, so with this concept, now we go to next exercise, which is very simple. As you can see, your integration by parts is also very simple. Just you need to keep a Lecture rule in your mind, remember, nothing more than that. 7.6 exercise. First question, integrate x sine x. You can see this is the product of two functions. Combinations of which two functions here? Combination of algebraic and trigo. Algebraic occurs first, so this should be your u and this should be your v, remember, according to Lecture rule. Now we'll write here by parts, integrating by parts. So u will come out, x will come out, integral of sine x minus inside the integral derivative of x with respect to x, which is 1, into integral of sine x, that is v, and then whole integral. This is what by parts. I repeat, u outside, integral of v, minus inside the integral derivative of u, that is du by dx, into integral of v and then whole integral. Okay. Now this x as it is, you know integral of sine. What's the integral of sine? Minus cos, you know. Here minus, same answer here, minus cos. So this becomes plus cos x dx. And now finally you have x cos x plus what's the integral of cos, which is sine, plus c. So this is the integral by parts. It is as simple as that, you can see. Question number 2 is same question. You have integral of x sine 3x. The only one thing you need to keep in your mind, when you integrate sine 3x, then this is linear function. So you have minus cos 3x by 3, remember, upon the coefficient of x. Keep this in your mind and do as I did here. Here directly you wrote integral of sine as minus cos. But in case of sine 3x, you have minus cos 3x by 3. Okay. Now I'll go to question number 3, third question. Integral of x squared into e raised to x dx. This is a combination of which two functions? Which two functions? Exponential and algebraic, remember. Exponential and algebraic. So according to Lecture rule, which occurs first? Algebraic and then exponential. So this should be u and this should be v. Exponential is the last and log is the first. Now we do it by parts. So I'll integrate it by parts here. If I use integration by parts here, which function will come out? X square will come out here. X squared outside, integral of e raised to x. minus inside the integral derivative of x square, which is 2x, into integral of e raised to x, and then whole integral. Okay, so this is equals to here x square. What's integral of e raised to x? E raised to x. 2 will come out because it is a constant. X as it is. What's integral of e raised to x? As you have written here, which is e raised to x. Now here you are through, remember, but here again the product of two functions. So we use integration by parts here again. X squared into e raised to x minus 2. Now again by parts. So x will come out, this is u, you know, exponential is always v, into integral of e raised to x minus inside the integral derivative of x, which is 1, integral of e raised to x, and then whole integral. Okay. So here you have x squared into e raised to x minus 2 times, this is x into integral of e raised to x is e raised to x. Here if you integrate it once, e raised to x. One more time you integrate it, again e raised to x. And at the end you write the plus c. So finally you are getting x squared into e raised to x minus 2x into e raised to x plus 2 into e raised to x plus c. If you want, you can take e raised to x common, x squared minus 2x plus 2 plus c. This is the required integral. Okay, now over here just one point I would mention here. This place you can do like this also, remember, if you want. If x into e raised to x dx, I can rewrite like this, you see, e raised to x, I'll write x minus 1, subtracting 1 and adding 1, minus 1 plus 1. Now what is the derivative of x minus 1? 1 and 0. So this is f and this is f dash. So according to that result, e raised to x into fx, that is x minus 1 plus c. Right? That's what you are getting here, you see. 2 is already there from the beginning, you can see here. 2 is already there from the beginning. Over here, you take e raised to x outside, so you'll get the x minus 1. This is your answer. Okay. Now, here, let's go to fourth question. X into log x. Combination of which two functions? You know, here combination of algebraic and log, remember. Recall the Lecture-12 rule. Log comes first, so this should be your u, remember, and this should be your v. Log is the first in the sequence, exponential is the last in the sequence. So I'll use by parts. What is integration by parts? Log x will come out, u will come out. Inside the integral, you have x minus, inside the integral, differentiation of u, that is log x, which is 1 upon x, into integral of v, which is x, and then whole dx. So here log x into x square by 2, integral of x, minus here 1 upon x into x square by 2. Now 2 will come out, and here you are just left with x. So this portion is just 1 by 2 outside and integral of x, remember, and this can be done in the next step. So finally what we are getting here is this log x into x square by 2 as it is, minus here 1 by 2 outside, and this is just x dx. And therefore you have log x into x square by 2 minus 1 by 2 into, what is this, x square by 2 plus c. This is the required integral. Next question, I'll go to directly 7. You can try the middle two questions. Integral of x sine inverse x, product of two functions. Which two functions? Algebraic and inverse. Recall the Lecture rule. According to Lecture rule, which function comes first? As per Lecture rule, which function comes first? Inverse comes first. So this should be your u and this should be your v, remember. As per Lecture rule, inverse comes first, then algebraic. Okay, so now we do by parts. Let's see. So here sine inverse x will come outside into integral of x minus inside the integral differentiation of u du by dx, which is 1 upon root of 1 minus x squared. You know derivative of sine inverse x, into here integral of x as I told you, and then whole integral. Fine. Now here at this place, the first portion, that is sine inverse x as it is. What is the integral of x? Which is x square by 2 minus inside the integral. This is x square by 2, same. So I'll keep 1 by 2 outside here. This is x square upon root of 1 minus x square dx. X square by 2, 2 are kept outside, x square. This is root of this expression here. Now, the question is how we'll integrate this. This is the question. So you need to recall one of the earlier method. I'll keep this one as it is. Sine inverse x into x square by 2 I'll keep as it is. The question is 1 by 2 as it is. How will integrate? This is the question. Okay, here I'll just call this as I1. I1 means this integral, and I'll call this as I. Usually in the beginning of the integral you can call that as I, and this is some new integral I1. So I'll find separately I1 and I'll place there. So I1 is x square upon root of 1 minus x square. Now your question is, you need to use the substitution. Later on as you learn further you will realize, but one of the substitution you can use it here. Put x equals to, for example, let's put sine theta. Trigo substitution I'm using. You know, once you use the substitution you need to differentiate it. Dx equals to cos theta d theta. Actually what I did, differentiating with respect to x. So here 1, what's the derivative of sine theta? Cos theta into d theta by dx. Dx I've written over here directly. So therefore I1 equals to, the integral I1 reduced to x squared, which is sine squared theta. What is dx? Which is cos theta d theta upon 1 minus sine squared. Here if you place times 1 minus sine squared is cos squared, so this is just cos theta. So finally we are left with sine squared theta d theta, integral with respect to theta. And you know how to integrate sine squared. You remember points to remember. How to integrate sine squared? Double angle formula. So I'm using this. What is sine square? 1 minus cos 2 theta by 2. Double angle formula for sine square, you know it. 1 by 2 outside. Integral of 1 with respect to theta, which is theta. I'm doing directly now. What's integral of sine cos 2 theta? Which is sine 2 theta upon the coefficient of theta, which is 2 plus c. Now you cannot keep the final answer in form of theta. You need to reduce in form of x. 1 by 2. Here you can use 2 sine theta cos theta. 2 will get cancelled, so just sine theta cos theta. Okay, so 1 by 2. What is theta? Go back to substitution. What is theta from this? Sine inverse x. minus, what is sine theta? You know x. What is cos theta? Cos theta you can write root 1 minus sine square. So this is 1 minus x squared plus c. This is I1, remember. So now finally we will come to equation 1. I means given integral equals to, you have sine inverse x into x squared by 2. 1 by 2 is already there, and this 1 by 2 gives you 1 by 4 into sine inverse x minus x into root of 1 minus x squared plus c. This is the required integral. Okay, so now almost you are through here, but if you want you can take sine inverse x common from this too. So if I take sine inverse x common, you'll get x squared by 2 minus 1 by 4 plus here 1 by 4x into root of 1 minus x squared plus c. And further, if you want, you can take here 4 as LCM. 1 by 4 sine inverse x. Here 2x squared minus 1. 4 is the LCM, remember. Plus 1 by 4x into root of 1 minus x squared plus c. So that I1 was very important portion here, remember. This was very important part here. Okay. Now for the next question here, let's go to question number 8. X into tan inverse x. Combination of which two functions? Which two functions? Algebraic and inverse trigo. Inverse occurs first, then algebraic. So this should be u and this should be v, remember. So we do it by parts here. Tan inverse x will come outside into integral of x minus inside the integral derivative of tan inverse x, which is 1 upon 1 plus x squared, into your integral of x and then whole dx here. So this is equals to tan inverse x into integral of x, which is x squared by 2 minus here same thing, x squared by 2. I'll keep 1 by 2 outside here, and this is x squared upon 1 plus x squared. Now again the other part integration, which is very important here. How will do that? It's if you observe quadratic upon quadratic. I already told you earlier, if you have quadratic upon quadratic, what we do usually, we set this expression over there, 1 plus x squared minus 1 upon 1 plus x squared, adding and subtracting 1. If you have quadratic upon quadratic, set the denominator expression over there. So x squared by 2 minus 1 upon 2, this upon this, which is 1 upon 1 plus x squared. Individual division, this upon this minus 1 upon this. Now you can see that this is very simple, because you can integrate this, you can integrate this. So tan inverse x into x squared by 2 minus 1 by 2. What is the integral of 1? Which is x. What is the integral of this one? You know, tan inverse x plus c. So let's simplify. Integration is over here. Tan inverse x into x squared by 2 minus 1 by 2x plus here 1 by 2 into tan inverse x plus c. You can take tan inverse and half common. So half tan inverse x I'll find common from this and this. So here you are left with x squared, and here you are left with 1 minus 1 by 2x plus c. question number 10 here, that is integral of sine inverse x the whole square. Now this is a single function, so what I'll do, I'll write into 1 and we do by parts. So I'll write sine inverse x the whole square into 1. Okay. Now usually single function is always u, remember. This is u, this is v. You cannot do other way around, think about it. By parts. Single function always should come out, remember. So now sine inverse x the whole square will come out into integral of 1 minus inside the integral differentiation of this. I am using chain rule considering this as x, remember. So 2 times sine inverse x derivative of x square 2x into by chain rule differentiation of this, which is root of 1 minus x square, into integral of 1, remember, and then the whole integral. So here this one as it is, sine inverse x the whole square. What's integral of 1? X minus 2 being constant, I'll keep it outside. Here sine inverse x as it is upon root 1 minus x squared as it is, integral of 1 which is here x dx. I repeat this portion. What I did is here, this whole square will come out, integral of 1 minus differentiation of this 2, this looks like x squared, so 2x into differentiation of sine inverse x by chain rule, that is this much. This is derivative, remember, and into integral of v, that is here. 2 being constant outside, this is as it is, this is x dx. Now again the important part is integration of this. How we'll do, that's the question. So now here the question is how to integrate this portion. So what you can do is, as we did earlier, I'll keep this one as it is, minus, I'll call this as just I1 and 1, where I1 is this integral. So we do separately integration of this portion, sine inverse x upon root of 1 minus x square into x dx. Now here the obvious observation is you have derivative of sine inverse x here. So what I'll do, I'll put sine inverse x equals to t. Why I'm doing this? Because once I differentiate this, what's the derivative of this one? Root of 1 minus x squared into dx equals to dt. You know differentiation here. So this portion becomes dt here. Sine inverse x was t. So this is t. What is x from this? That you need to convert in form of t. So x is sine t here. Take sine on the other side. So t sine t. This was your t. X is sine t. And this portion is dt here. Okay. So now this is again, you can do by parts. Integration by parts. Combination of, you can see that here, algebraic and trigo. So algebraic occurs first, then trigo. So this is u, this is v here. So I'm doing directly here. I'll drop one step here. T will come out. Integral of sine. What's the integral of sine? Minus cos. Minus inside the integral differentiation of t with respect to t, which is 1. Integral of sine, which is minus cos. So this becomes plus cos t dt. Okay, and now finally minus t cos t plus, what is the integral of cos here? That is nothing but the sine t plus c. And now I'll reduce each of these in form of what? X, remember. Okay. What is t? T is sine inverse x. So here I'll write sine inverse x into What about cos t? That you don't know, but you have sine t here. So I can write root of 1 minus sine square, but sine square is x square. So I'll write directly this. What is sine t? That is x and plus c. Right? The conversion on given variable is important, remember here. I repeat what I did. T. What is t? That you know, sine inverse x. Now cos t we need to convert in form of x. Now I don't have cos t, but I do have sine t. So what I'll do, instead of cos t, I'll write root 1 minus sine square t. You know this is exactly cos t. 1 minus sine square is cos square and cos t. But what is but what is sine t? That is x. So you have this much. What is sine t? That is x plus c. So finally, your solution reduced to here by 1. You can call I means the given integral here. I means given integral here. I equals to sine inverse x the whole square into x minus 2 into I1. The I1 is this, sine inverse x into root of 1 minus x square plus x and at the end plus c, remember. So finally we are getting here sine inverse x the whole square into x. This 2 will go inside, so this is plus 2 into sine inverse x into root of 1 minus x square, and this is minus 2x plus c.